Good morning, everyone. Did you know that every 14 seconds, someone becomes a victim of credit card fraud? That's over 6,000 people every single day losing their hard-earned money to criminals. Today we're diving into our project called Credit Card Fraud Detection System. This project is presented by Anish Chakrabarti, Akash Karal, Adil Dioka, and Akash Thait. We're going to show you how technology can fight back against these financial criminals. Main content. So what exactly is credit card fraud? Credit card fraud happens when someone uses your credit card information without your permission. This can mean stealing your physical card or just getting hold of your card details. Once they have this information, they can make purchases online or in stores. They might buy expensive items, withdraw cash, or even sell your information to other criminals. The scary part is that this can happen to anyone, anywhere, at any time. Your card details can be stolen through fake websites, card skimmers at ATMs, or even data breaches at stores you trust. Most people don't realize they've been targeted until they check their bank statements. By then, hundreds or thousands of dollars might already be gone.
Let's understand how fraud happens. Let's start with situation 1, the phishing website trap. Sarah gets a text message at 2 p.m. saying her bank account needs immediate verification. The message looks official with her bank's logo and everything. Worried about her account, she clicks the link without thinking twice. The website looks exactly like her real bank's site. She enters her credit card number, CVV, and expiration date. Within 5 minutes, the fraudster is already using her details to buy expensive electronics online. Sarah only realizes something is wrong when she gets transaction alerts an hour later. Now let's look at situation 2, ATM card skimming. Mike stops at his usual ATM to withdraw cash for lunch. What he doesn't see is the tiny device attached to the card slot. This skimming device copies all his card information when he slides it in. A hidden camera also records him typing his PIN number. The next morning, the criminal creates a duplicate card with Mike's information. They withdraw money from different ATMs across the city. Mike discovers the theft only when he checks his account balance later. Finally, situation 3, the lost or stolen card scenario. Emma drops her purse while rushing to catch a bus. A stranger finds her credit card and decides to keep it. Before Emma even realizes her card is missing, this person is already shopping. They buy gift cards at a grocery store because no ID is required. Then they use those gift cards to purchase items online. By the time Emma calls to block her card, multiple transactions have already gone through. Each of these situations shows how quickly fraud can happen. The key is that criminals count on people not paying attention. They also rely on victims not acting fast enough when something goes wrong.
Let's see how traditional system works. Let me start by explaining how traditional fraud detection works. Banks collect your transaction data and create fixed rules based on past fraud cases. For example, if you spend more than usual or make purchases in different locations, the system flags it as suspicious. The problem is these rules are static and can't adapt to new fraud patterns. Fraudsters are getting smarter, but the detection systems remain the same. Let's see how we can solve this situation. This is where MLOPS comes in with a completely different approach. Instead of fixed rules, we use intelligent models like Random Forest and XGBoost. These models learn from data and continuously improve over time. Let me walk you through the 9-step MLOPS process for fraud detection. Step 1 is data ingestion, where we collect transaction details like amount, time, location, and user behavior. Step 2 involves data pre-processing, where we clean the data, handle missing values, and normalize everything. Step 3 is feature engineering, where we create smart indicators like transaction frequency and unusual spending patterns. In Step 4, we train our machine learning models using Random Forest and XGBoost algorithms. Step 5 evaluates these models using accuracy, precision, and recall metrics to pick the best one. Step 6 deploys the chosen model as a real-time fraud detection system. Now here's where it gets interesting. Step 7 has 2 levels of monitoring. First, we monitor model performance to catch data drift, and ensure accuracy stays high. Second, we collect feedback from real-world usage, including fraud complaints and false positives. Step 8 uses this feedback and new transaction data to retrain the models continuously. Finally, Step 9 automates the entire process using CI/CD pipelines for fast updates. The key difference is the feedback loop that makes the system learn from mistakes. When the system incorrectly flags a legitimate transaction or misses actual fraud, it learns from these errors. This continuous learning makes MLOps-based systems much more accurate than traditional.
Let's see how containerization helps in our implementation. Docker has revolutionized the world of fraud detection systems, functioning like a shipping container for software applications. Just as physical shipping containers facilitate the seamless transfer of goods across trucks, ships, and trains, Docker containers encapsulate your entire fraud detection system into a portable unit. This means your machine learning models, such as Random Forest and XGBoost, along with all their dependencies, can operate uniformly on various platforms, from your laptop to cloud servers, without a hitch. Before Docker, deploying machine learning models often felt like a daunting nightmare. You would train a model on one system and then spend countless hours or even days trying to get it to function on a different system, grappling with mismatched software versions and missing dependencies. Docker completely eradicates this issue, ensuring your fraud detection system can start up rapidly and run consistently, no matter where it is deployed. In fraud detection, every second is crucial. Timely detection can prevent significant financial loss. Now, let's introduce ONNX, or Open Neural Network Exchange. Think of ONNX as a universal translator that empowers machine learning models to communicate across different frameworks. You might develop a fraud detection model using a specific framework, but when it's time to deploy it on a different platform for enhanced performance, ONNX steps in. It converts your trained models into a standardized format compatible with various systems. However, the benefits of ONNX extend beyond compatibility. It also enhances speed. Speed is essential in fraud detection. When a scammer attempts to use a stolen credit card, immediate action is critical. ONNX optimizes your models to run faster, reducing latency when transactions are evaluated. When paired with Docker, ONNX creates a powerful alliance. Docker can package your ONNX optimized models into containers ready for instant deployment. This synergy establishes a robust MLOps pipeline. A fraud detection system powered by this combination can effortlessly scale during high-demand periods, like Black Friday, handling millions of transactions every minute while maintaining consistent performance. The beauty of this architecture lies in its remarkable flexibility. If an update to your fraud detection algorithm is needed, deploying a new Docker container containing your improved ONNX model is a breeze. This process is accomplished without downtime, compatibility issues, or the headaches that traditional systems often impose, which are frequently tied to specific hardware or software configurations, making scaling a cumbersome task. Thank you.